Lesson 3.1, Geometric Sequences, is our first lesson as part of R10, which is all about geometric patterns. So a geometric sequence, similar to an arithmetic sequence, is a series that forms a set of data that forms a pattern. But instead of adding to get your next number, you are going to multiply each term after the first term by some sort of constant number, just like we added a constant number every time to our arithmetic sequences in order to get our next term. So we're given the example 3, 9, 27, 81. This is a geometric sequence, and every time they are multiplied by 3. So that is my kind of change that we talked about in class. So the multiplier is no longer called the common difference, but is now called the common ratio. So R is 3. The common ratio can be any non-zero real number. So it can be positive, it can be negative, it can be a decimal, it can be a fraction. Anything that isn't 0, that also isn't the square root of a negative, is fair game. There's a typo there. Okay, so 9 divided by 3 equals 3, which gives me my R value. I could have also gotten this by taking my third term divided by my second term. So basically, you can continue forever in this manner. Any term divided by the term before it should give you your R value. So if we look at the following, 16 divided by 4 is 4. 1.5 divided by 0.5 is going to be 3. 1.6 divided by 2 is a little bit trickier. You could convert this by multiplying by 10 to get 16 over 20 would be the same, an equivalent ratio. Okay, and then from there you could figure out that actually that could be reduced to 8 over 10 or 0.8. This could even be reduced further to 4/5. So you could also write it as 4/5. You're not obligated to use a decimal. You can use a fraction, but you are allowed to use a calculator, so you can have a decimal as well. Okay, so just some other terminology that we need to be familiar with here. When we look at a sequence that keeps increasing, so we're multiplying by a bigger number, we still call this an infinite sequence. Now we call it an infinite geometric sequence. Okay. When we don't include the ... it is now called a finite geometric sequence because it stops after a fixed number of terms. In this particular case, we stop after term 4. We can still refer to a sequence as increasing if it's going up and up and up forever. It's also divergent in this case because they keep getting farther and farther apart. That space between your terms keeps getting bigger, and so they do not approach a constant value. We call this divergent. This particular example, half, quarter, eighth, 16th, and 32nd, is decreasing. It's going downward towards 0, which means it's also convergent because the spaces between, or the difference between our values is getting smaller and smaller. Okay, so divergent means difference is getting larger, and so it's not approaching a constant value. Convergent means the difference is approaching this constant value, so it's getting smaller. Okay, you can have an increasing convergent sequence. You can also have a decreasing divergent sequence. Okay, those are still possible things. Just these particular examples pair increasing with divergent and decreasing with convergent. An example of the other would be if we go from 1 to 1.5 to 1.75, etc. Okay, that would be an increasing convergent sequence, a decreasing divergent sequence. So this is increasing and convergent. A decreasing divergent sequence would be something along the lines of -2, -4, -8, -16, etc. We can also end up in a scenario where it's not increasing or decreasing. Okay, this particular example, we have alternating positive and negative values. Okay, when we end up in that sort of scenario, it's not increasing or decreasing because we keep going back and forth between the signs. It is, however, divergent because it is still getting to have larger and larger differences between the consecutive terms. So think about it. Why can R not be 0? That's my only requirement. Well, if I told you that term 1 was 6 and that R was 0, what would term 2 be? Well, term 1 times R gives me term 2, so it would be 0. And term 3 would be 0 times 0 is 0. And term 3 times 0 would be term 4, also 0. This is not a sequence. Doing nothing does not create a sequence. Okay, so R cannot be 0.